Right now, 80% of America uses fossil fuels for energy. However, there are a lot of negative impacts that can come from this. First of all, fossil fuels need to be combusted to use them, which releases greenhouse gases like carbon dioxide. These greenhouse gases go into the atmosphere and trap infrared rays that the Earth reflects when hit by sunlight. An increase of infrared rays causes global warming, which is bad for the environment. Also, fossil fuels are depletable, meaning by the end of this century we will probably run out of them and will need a new energy source. But scientists may have an answer to this problem: nuclear energy. The main way scientists create nuclear energy right now is through nuclear fission. Scientists take a large nucleus, like uranium-235, meaning a nucleus with 92 protons and a total nuclear mass of 235 atomic mass units. Since uranium-235 is radioactive, it can decay to release energy in particles to make smaller, more stable nuclei. This reaction is set off by bombarding uranium nuclei with neutrons. The uranium then splits into barium-141 and krypton-92, releasing 3 more neutrons to trigger more reactions. However, when this reaction happens, the total mass of the products is actually less than the total mass of the reactants, uranium-235 and a neutron. Albert Einstein discovered that this lost mass is actually converted to energy, and the amount of energy released can be calculated using his famous equation, E equals mc squared, where E equals the amount of energy released, m equals the mass, and c equals the speed of light, or about 3 times 10 to the 8th meters per second. This heat energy produces steam, which turns a turbine that runs an electric generator and creates electricity. Using fission to create energy this way can have lots of advantages. Since the only products are smaller nuclei, neutrons, and energy, there is no greenhouse gas emission, so global warming isn't a concern. This process creates a lot of energy from just a little fuel, so it is very effective. Without using fossil fuels, America would no longer need to depend on foreign countries for oil. These advantages are why almost 20% of the USA is currently powered by energy created through nuclear fission. However, there are some problems with nuclear fission. The products of these reactions are radioactive, meaning they can still continue to decay. However, radioactive atoms still have the same number and configuration of electrons as normal atoms. This means that they have the same chemical properties as the atoms that make up our blood, bones, and tissues. As a result, when somebody is exposed to radioactive particles, these atoms can be incorporated into their body's tissues and can decay, causing cancer and other mutations. Sometimes these mutations can occur in reproductive cells, which could cause health issues for the next generation. Exposure to radioactivity can also trigger radiation sickness, which causes nausea, fatigue, hair loss, and potentially cancer. The main issue with all of these negative health impacts of exposure is that we really have no place to store radioactive material safely in the long term. A place for long-term storage should be dry, since if there is water, radioactive material can infiltrate the water supply. It should also be far from cities and towns so that nobody can be exposed to radioactivity. Scientists have turned to Yucca Mountain in Nevada, since it's located in the middle of the desert and far from urban centers. However, there might be issues with storing nuclear waste here in the long term, since some water has been detected and nobody knows how climate change will affect the mountain's ability to hold waste. So for now, we can't kick nuclear energy into high gear since we need a sustainable place for storage first. Also, in the past, there have been terrible malfunctions at nuclear power plants. The worst one, in Chernobyl, Ukraine, has caused up to 4,000 deaths, either immediately or in the long term by radiation sickness. For all of these reasons, nuclear fission needs to be made a bit more safe before we can increase our use of it. There's another promising way to harness nuclear energy: nuclear fusion. Unlike fission, fusion involves fusing smaller nuclei to make larger ones. This occurs when hydrogen-3 and hydrogen-2 nuclei join together and then split into helium-4 and a neutron. Like fission, some mass is lost in this process, and it is converted into energy. This is the same process that stars use to create energy, and it actually created every element by fusing to make bigger and bigger nuclei. Nuclear fusion has huge potential. It creates far more energy than fission, but it has no nuclear waste since the products are just non-radioactive helium and neutrons, so there are no negative health impacts from the process. It is also fueled by hydrogen, which is extremely abundant, so we wouldn't have to worry about depleting our resources. Sounds great, right? Well, the only problem is that it's almost impossible to do. The reason it works so well in stars is because of their high temperature and pressure. In order for the process to occur, all the material needs to be heated to the plasma state at several million Kelvin. So far, no scientists have succeeded in making a fusion reactor. Hopefully, Scientists can figure out either a way to safely store radioactive waste from fission, or to achieve the heat necessary for a fusion reactor. Who knows? Maybe in a few years we might all be using nuclear energy.